Hey everybody, this is Michael from Barton Musical Circuits. This is the Rectifier and Recombiner module. This is a module that has two parts to it, a mixer and rectifiers that I'm calling the rectifier, and then a recombiner, which is rectifiers going into a mixer. This is a pretty simple one. Hopefully this isn't a very long video. So let's start with the rectifier section and the very beginning. We've got three inputs. These are PCB mounted jacks over here. The sleeves are grounded. You could also ground the switches on these if you were worried about having a lot of noise, but I don't think it's necessary. This is a mixing stage that they're going into. These 100K resistors are all going to this op amp with a 100K resistor in its feedback path. So this creates a gain of -1, and so we have an inverting mixing stage. The one difference between these three inputs is the AC in goes through this 0.1 UF capacitor in addition to the 100K. So this is going to form a slight high-pass filter, which is going to take any DC bias off of it. So if you've got a VCO that you're not sure if you've got the offset quite right on it, going through the AC in is a way to make sure that it's going to be biased at 0 volts. The DC inputs are there if you wanted to rectify an LFO or some kind of AR generator's output, and they're also useful for adding a DC offset to an AC signal or to another DC signal. So you could have a very, very slow LFO going to one of these that would then make it so that the rectified signal is going to be rectifying at different points, because the overall voltage would change on the output when you sum all these voltages up. These are going to go through these 100K resistors to these inverting precision half-wave rectifier stages. The way these half-wave rectifiers work is pretty similar to just a regular inverting gain stage, but with a couple differences. So if we look at this, it's pretty close to when we look at this. We've got 100K resistor input, 100K resistor feedback, and the positive input is grounded. The difference is going to be the two diodes in there. So this first diode is, oh my God, bad arrow. It's going to flow that way. I'm getting used to using a trackball instead of a regular mouse, and so sometimes stuff looks funky like that. What this is doing is it's sending outputs of the wrong polarity back to the negative input, and there's no resistor in there, so it should be ideally infinite negative feedback when it's the wrong polarity, and it will just go back down to ground. In the real world, there's no actual infinite negative feedback, but it's close enough. This other diode is going to only pass the correct voltage, and that's going to go to our output through this 1K resistor, and then it also has this 100K feedback resistor here, which is going to give it a gain of -1. And now, the big difference, though, as we saw on the regular inverting gain stage, the 100K just goes straight to the output. Here, we're tapping it off the other end of this diode. And the reason we're doing that is because diodes have what's called a diode drop. You lose a little bit of voltage from the diode itself. And by tapping it on this side, we're going to have our negative feedback account for that. The output of the op amp will actually just adjust for that diode drop. And so yeah, this is the positive output. So the negative voltages off of here are going to get turned positive here, and the positive voltages are going to be 0 volts here. And up here is the negative output, and it works the same way, just the diodes are flipped around. So positive voltages here, which were the negative voltages on the input, because this is an inverting stage, those will be negative here and vice versa. So the outputs of these are also going to the switches of the return jacks. And I call them returns, but really it's an input to a separate section. The idea behind this module is that you would rectify one half of the signal, process it somehow, and then recombine it with the other half of the signal to create harmonic distortion in addition to whatever kind of processing you're doing, filtering or what have you. So These are the same circuit, a half-wave inverting rectifier for both of these. And then the difference is on the first one, we were inverting it and then rectifying it with inverting rectifiers. Here we're inverting, rectifying it, and then inverting it with this output mix stage, which then goes to the mix out jack. Yeah, that is how this circuit works. I'm sure there's a better explanation for how op-amp half-wave rectifiers work out there. Thank you for watching.